Hey guys, welcome back. Today we are starting on the bottom of page 6 in your notes. We're talking about areas of circles and sectors today. So let's start out with the formula for area of a circle. Area of a circle is equal to pi r squared, where r represents the radius. Note that when you're finding these, you need to use the pi key on your calculator, not a rounded version such as 3.14. So on your calculator, if you hit second and then the up key, that'll give you the exact value of pi to use in your problems. All right, let's do a problem together. We're going to follow the same steps, ESSA plus. First, we write the equation, this circular putting green. The formula for the area of it would be pi r squared. Now, they gave us the entire length all the way across the circle, which represents the diameter. And remember, the diameter is equal to 2 times the radius, or in other words, the radius equals half the diameter. So to find the radius, if the diameter is 20, we need to take half of 20, so our radius should be 10. So we'll fill that in, substitute 10 in for the radius. And then to solve this, you need to square 10 first. That gives you pi times 100. Pi times 100, the exact value is 100 pi, but they asked it for the nearest square foot. So this one you shouldn't really need to plug into your calculator because we're just rounding to the nearest square foot. Pi times 100 would be 314 feet squared. Go ahead and try the practice problem at the top of the next page about the archery target. Okay, check your answer on this one. They won't always ask us to find the area. Sometimes they'll give us the diameter or the radius they'll give us the area and ask us for the diameter or the radius. So let's do a problem like that. This one says that the area is 95 centimeters squared. So we'll substitute in 95 for A. Now we need to solve it for R. The first step is to divide both sides by pi. Next, we need to square root both sides to get R by itself. So we know that R is not going to be negative, so we know R is just going to be the positive form of whatever this is when we plug it into our calculator. So this would be the exact answer, but they didn't ask for exact or approximate. They didn't specify, so we can just go ahead and plug this into our calculator if you want to get 5.499, which means that the radius is about 5.5 centimeters. Try the practice problem below. Okay, here's the answer to that problem. If you got 14, you were very close. Just pay attention to what they're asking you for. This problem is a little different from the last one because they asked for diameter. And also notice on this one, when you divide by pi on both sides, it actually cancels out on the left side as well, leaving you with just radius squared equals 196, which is a perfect square. So we know the radius is 14, double that to get the diameter, 28. Next, we're looking at the areas of sectors of circles. Sectors are basically just a piece of the circle. It's like a pie piece or a piece of pizza, something like that. So what it is basically a fraction of the circle's whole area. So the formula for it is the fraction, which we can get by taking x over 360 times the whole area, which we know is pi r squared. X in this formula represents the central angle measure. So it's that angle made at the center of the circle by these two radii. Let me show you an example real quick for central angles. For example, let's say that we're looking at a central angle measure of 90 degrees. And we're looking at this piece of pizza or pie or whatever. For this, x is equal to 90 since the central angle here is 90 degrees. And let me show you how that gives you the fraction of the circle. So if we put 90 over 360, wouldn't that give you reduced to 1/4? And isn't that what fraction of the circle we're looking at here? Hopefully you're saying yes to all these. If you're not even given the central angle measure, if you know the fraction of the circle, that's enough to solve for the area of this sector. Think about it. If you wanted to find the area of this shaded piece, couldn't you just take the area of the whole circle and divide it by 4? Dividing by 4 is the same thing as multiplying by 1/4. All right, let's do a practice problem for this. So this one says the circular pizza has the diameter 12 inches. I would suggest drawing a sketch. It doesn't need to be perfect. And it's cut into 8 congruent slices. What's the area of one slice to the nearest hundredth? This slice of pizza is represented by a sector. So we know that the formula is going to be what we just wrote down, x over 360 times pi r squared. Now, we could go ahead and find that central angle measure by dividing 360 degrees by 8. However, it's not really necessary because we already know what fraction of the circle we're talking about. This one piece of pizza is 1/8 of the entire circle, or the entire pizza. So if we take 1/8 of the whole area, it'll give us the area of this one piece. So remember, the radius is half the diameter, so the radius on this is 6 inches. Now, we can simplify this first. So we have 1/8 times pi times 36, which gives us 36 pi over 8, or 4.5 pi would be the exact answer. But they asked for the answer to the nearest hundredth, so we can go ahead and plug this into our calculators. That gives us 14.137. So if we round this to the nearest hundredth, it will round up since 7 is greater than 5. So the area of one slice is about 14.14 inches squared. All right, try the practice problem on the next page with the color wheel. And then there are 3 problems for you to do that are not word problems, but just extra practice with the formula. All right, here are the answers to those. For the first one, the word problem, notice that they gave you the diameter, so you first need to find the radius by dividing that by 2. And to figure out what fraction of the circle we're talking about, it told us that it's divided into 12 congruent sections. So we know the denominator of our fraction is 12, and then it's asking for just the area covered by green. That would be 3/12 of the entire circle, which reduced is just 1/4 of the entire circle. So you could, again, find the central angle measure if you wanted to by dividing 360 by 12 and then multiplying that by 3 since there's 3 sections. But it's not really necessary if you already know the fraction of the circle you're talking about. Plug that in for the fraction of the circle, plug in 5 for radius, and you'll be able to solve it from there. For these below, the most difficult one, I think A and B are pretty easy. They should have been easy for you guys. You're just plugging in and then plugging into your calculator. For C though, before you substitute in, you first have a step before that. So 65, if you plugged in 65 for X, just be careful because they're asking you for the area of the shaded portion. If you plugged in 65 for X, you're finding the area of the non-shaded portion. So what you need to do first is we know that an entire circle is 360 degrees. So if you subtract 360 minus 65, that'll give you the leftover piece for the actual central angle of the shaded piece. So that's 295 degrees. That's what you need to plug in for X. All right, your homework tonight, you have problems for goal 5 and 6. They're on page 801. And then you have the reflection question number 44 in the book. Have a great day, guys. I'll talk to you tomorrow. Bye.